In this video, we're going to look at exploring numerical variables, and specifically we're going to talk about the quartiles, the 5-number summary, and the box plot. So the first quartile is defined to be Q1, which is the n plus first over fourth ranked value. And we'll see what that is via an example in just a few minutes. And the third quartile is Q3, which is 3 times n plus 1 over fourth ranked value. And what do these quartiles do? Well, the first quartile, the median, and the third quartile put together help us separate the data into fourths, essentially, in an ordered array. So some extra notes here, because these values may not be integers, we have to note down a few things, and that is that if the calculated rank is a whole number, then pick the corresponding, or the measurement, or the ranked value, the measurement corresponding to this ranked value. If the calculation is a fractional half, take the average of the measurements. If the calculation is a fractional half, take the average of the measurements on either side of this ranked value. And then finally, otherwise, choose the closest ranked value. For the measurement. Okay, so let's do some examples here. So suppose we have 7 data points, and you'll want to put those into an ordered array. So what do? Let's suppose we just have the data points 5, 7, 7, 8, 12, 1, 2, 3, 4, 5, 6, 7. So let's suppose we have these 7 measurements. Well, you all know that the median is the middle number, so we find that that is 8 is our median. But what is our first quartile and third quartile? Well, Q1 is equal to the n plus 1 over fourth ranked value. N here is 7, because we have 7 objects. So this is 7 plus 1 over 4 equal to the second value. Right? So we have our first value, second, third, fourth, fifth, 6th, and 7th. And so we pick our 7th value. So Q1 is equal to 7. Q3 is 3 times n plus 1 over 4th ranked value. So this is 3 times 2, so the 6th value in our list. So that means that it is, Q3 is 15 here. Okay, well that was an easy version because these worked out to be integers. But real quick, what happens? Let's suppose we have 5, 7, 7, 8, 12, 15, 20, and 22. So 1, 2, 3, 4, 5, 6, 7, 8 values. Then if this was our data set, we have n equal to 8, and Q1 is the n plus 1, so 8 plus 1 over 4th ranked value, which is 9 over 4, which is 2.25. So if we look back at what we said, if we get a fractional choice here, and it was a half, then we take the average of the measurements around that number. But otherwise, we just choose the closest ranked value. So that's what we got here. So with 2.25, we choose the second value. So Q1 is equal to 7, because we choose the closest one here. All right, and what is Q3? Well, that is 3 times 8 plus 1 over 4, or in other words, 2.25 times 3, which is 6.75. So we choose Q3 equal to our 7th value, which is 20. Right, so we'll look in here. Our 7th value, 6.75, is closer to 7, so we choose 20 as our Q3. What if we have a similar data set? Let's just add one more. So 5, 7, 7, 8, 12, 15, 20, 22, 30. Why not? Well, we have our first point, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. And so now we get Q1 is equal to 9 plus 1 over 4, which is 2.5. So we take the average of the values between, are at 2 and 3 here. So those are 7 and 7. We take the average of those. So Q1 is equal to 7. Q3 is the 3 times n plus first over 4th ranked value. Well, that's 2.5 times 3, which is 7.5. So we look back at our data. So 7 and 8 is here. 7.5 is right there. So we take the average of 20 and 22. So Q3 is 21. And that is how we calculate our first and third quartile, given the 3 possibilities of our outcomes of this calculation here. Specifically of this calculation here. Okay. Now, there are a couple of things we want to say about the about these quartiles. And first is, we define something called the interquartile range, which is Q3 minus Q1. What does this do? This tells us where our middle 50% of the data is according to an ordered array. So it's the middle 50% of the data according to an ordered array. In other words, it's where exactly 50% of the data points lie. All right. Then in a similar statement, we have something called the 5-number summary that uses the values, the x smallest, so the smallest value in our data set. The second number is Q1, the third number is the median, the fourth number is Q3, and of course the fifth number is the largest value in our data set. And if you put all of this together, this actually gives us a type of plot called a box plot. And a box plot is exactly this. Where we draw a line on some kind of graph that tells us the smallest value. This box right here is our interquartile range. It's where our middle 50% of the data lies. And we have this box goes from Q1 to Q3, and we have a line here in the middle at the median to show us where that is. And again, we have this piece out here until we get the largest, x largest. And so, real quick, I can draw one more picture before we get out of here. So with this video, I want to do this one last picture. And suppose we have a set of data that is left skewed. Well, in a set of data like this, we're going to have the median be somewhere around here. And we might see something like Q1 here and Q3 here, and then x largest, x smallest. So our 5-number summary, or our box plot, which is our visual representation of the 5-number summary, might look something like this. Notice the median doesn't have to go in the middle of this box here. And notice the tail on this end on the right side is a lot smaller than the tail on the end of the left side. So if we see a box plot that looks like this, this suggests our data was left skewed. Similarly, if we have something right skewed, then the tail on the right side will be much longer than the tail on the left. And that's where we will end this video.